Here's an example of a problem you can do with finding the equations of tangent lines. We're using the implicit differentiation. So because they want equations of tangent lines, you're definitely going to need to be taking a derivative. So this is good too. We can look again at a product rule. So 1d2 plus 2d1. So your derivative would be the first times the derivative of the second would be 2y dy dx, plus the second times the derivative of the first would just be 1. Minus 5 goes away, y squared becomes minus 2y dy dx, and then equals 1. They want you to find the derivative at a specific point. So what I'm going to do first is I'm going to solve for dy dx like we've been doing. So I'm going to end up with, I'm just going to rewrite that as 2xy dy dx. I'm going to move the y squared to the other side, and I still have minus 2y dy dx. Factor out dy dx. To solve, you get 2xy minus 2y, 1 minus y squared, so you should get dy dx is equal to the 1 minus y squared over 2xy minus 2y. Now what we would do, because they're giving you a specific time at x equals 3 to plug in, well, however, we got to plug in an x and a y. So what I need to do is I need to go back to this original equation here and plug 3 into that first. So when I do that with xy squared, there's your whole equation. I need to replace x with 3. So 3y squared minus 5 minus y squared equals 3. Now I have an equation that I can look to solve here. So I get 2y squared is going to equal 8, meaning y squared is 4. That means y equals positive or negative 2. So really what this means is I have two different points to look at. The 2 points are 3, 2 and 3, negative 2. So I need to find this slope at both of those points. So what I need to do is I need to say, well, at the point 3, 2, the derivative is equal to something, and at 3, negative 2, the derivative is equal to something. So what I'm going to do there is I'm going to plug those values now in to the derivative function we just found. So this is 1 minus 2 squared, and on the bottom you got 2 times 3 times 2 minus 2 times 2. So my numerator becomes, what, negative 3. My denominator here becomes 12 minus 4, which is 8. This one here, 1 minus negative 2 squared on top, well, that's still going to be negative 3. My denominator now 2 times negative 3 times 2 minus 2 times negative 2. So my denominator is going to be, oh, what do we got here? Negative 12 plus 4. Helps if I make the right thing negative. It's still positive 3, but it's negative 2. So there we go. So 6, negative 12, plus that is negative 8. So that then, yes, becomes 3 over 8. What they wanted was equations of the line. So this is now the easy part of this entire problem, is just finishing it off by plugging in a slope and a point. So y minus y1 equals mx minus x1. You're going to do that for each of your equations, and you're just going to plug in the values that you know, which are, for the first one, the point was 3, 2, the slope was negative 3 over 8, and at the point 3, negative 2, you have a slope of positive 3 over 8, and there are your two equations of the tangent line for this problem. So there's how you find all tangent lines given a generic value.